Good morning. Good morning, Atharva. We'll start the class in just 1 minute. Let me एक 2 मिनट में क्लास चालू करेंगे. जस्ट ये स्लेट एडजस्ट करने दो. How are you all? Hello everybody, are you fine? चलो सर, क्लास चालू करने का क्या? $56 students are there. Chalo, thanks. So I will share the screen with you. So in the last class, we were discussing about the braking force or the stopping distance. Here we have discussed that the braking performance of the vehicle, we consider that the vehicle is moving along the x direction with certain velocity. You apply the brake, then the general braking equation along the x direction which I have written. Now, if you do not consider the, you can say aerodynamic drag, we have derived the expression for the stopping distance. Here, we came to know that the stopping time and stopping distance that doesn't depend upon the mass of the vehicle. So that is the first conclusion we could able to draw from that. Then we discussed the aerodynamic drag, the effect. Then most of the time the vehicles, they are given this spoiler like this, and this is the vehicle without spoiler. The effect of what they if you go to the automobile dealer, then the person who is selling vehicle to you, he will say that this basically this vehicle with spoiler will give you more average and all, but that is not the means I have not seen any kind of literature which claims about the increase in the fuel economy. So the basic purpose which we used to do it in the company is basically to the backside of the vehicle should not get accumulated some amount of dirt. So that was the purpose. So that is why we used to provide the spoiler so that you can divert the air from the vehicle body away. Okay, now today we are going to discuss the or derive the expression for the braking force or stopping distance with respect to or deceleration with wind resistance. So, or you can say the expression for the stopping distance with respect to the aerodynamic drag if we consider the aerodynamic drag. Lecture 23. Now deceleration of the vehicle with deceleration of vehicle with wind resistance basically. So here we say that the aerodynamic drag on the vehicle the aerodynamic drag on the vehicle depends on the frontal area of vehicle and velocity of vehicle. Okay, so you can say that the summation of the forces, the summation of all external forces, that is equal to FB plus CV square, where you can say that where we can see that the FB is the total braking force, the braking force of front and rear wheel, and C is basically aerodynamic drag factor. So if we do the summation of the force balance, then we can say that this is the horizontal surface on which the vehicle is moving. This is the front and rear wheel of the vehicle. Okay, so this is the front of the vehicle. Here it is light. Now you got to have the weight of the vehicle which is acting on the horizontal direction. The drag force, this is V, the drag force CV square is acting here. Now the inertia force, this is W by G into, let us say that the acceleration. So this is your rear braking force. You can say that this is mu into RR, the reaction at the rear wheel, and this is the braking force at the front wheel. So F suffix FB, and so if we write down the equation here, we say that W by G into whatever acceleration or deceleration is equals to, in bracket, FF of B plus FR of B bracket complete plus CV square. So this is the equation. Then we know that this equals to minus M dV by dt. Since this is deceleration, we are putting the minus sign. So we can say that this is FB plus CV square. We have said here the front and the rear wheel. So we can also write down this as minus of M dV, as we know that this is dx by V, that is equal to FB plus CV square, because your V is equals to dx by dt. So we have replaced dt by dx by V. So if we simplify this, then we can write down minus V dV is equal to FB plus CV square by M. This is dV by dx. The M is the mass of the vehicle. So if you further simplify, it is VDV is equal to अभी इसको क्या करेंगे, ये सी v स्क्वायर हो गया, सो VDV डिवाइडेड बाय FB plus CV square, that is equal to minus of dx by m. Okay, so finally you can write down that this equation 0 to stopping distance or any distance x dx, that is equal to m integral of v0 initial to final speed 0, that is v dv divided by fb plus cv square. So sir, can you find out the integral when we say that from 0 to, let us say, dx is sd? Okay, so from here get the value of sd, stopping distance sd. Sir, please evaluate this integral. Use the integration formula, integral so it is x divided by, so we can use this formula, sir. If you permit, integral x divided by a square plus x square into dx, so that is equals to half log of a square plus x square. Sir, can we use this formula here for integration? Sarvesh, can we use this formula? Sir, please let me know what is the value of SD. Yes sir, please प्रद्युमन बताइए. m by 2c log of fb plus cv square by fb आएगा ना सर कि नहीं? So this comes out to be m by 2c log of in bracket fb plus cv square divided by fb. ये लिमिट का यूज करेंगे तो सर, so this is basically the formula for the stopping distance with aerodynamic drag. So this is the formula for stopping distance with aerodynamic drag. तो सर क्लियर हो गया? So please understand that with the aerodynamic drag the things become little bit complicated. So can we solve a numerical based on this? Yeah. So write down. Consider a light vehicle. This is the problem. This is page number 1. Consider a light vehicle weighing 3635 kg performing a full stop from 60 km/h on a level surface with brake application, okay, that develops a steady brake force of a steady brake force of 5000 Newton. Determine the deceleration comma stopping distance time to stop energy dissipated and the brake horsepower, or it should be brake power, ये मैं हॉर्स पावर जो है that is used in the MKS system. So brake power at initial application and averaged over stop and averaged over stop, neglect aerodynamic and rolling resistance forces, neglect aerodynamic and rolling resistance forces. सर ये प्रॉब्लम अच्छी तरह से पढ़िएगा, तो काफी सारी चीजें पूछा है. So consider a light vehicle weighing 3635 kg performing a full stop. That means final velocity is equals to 0. So VF is equal to 0. V initial VI is given as 60 km per hour. On a level surface with a brake application that develops a steady brake force of, that means he has given you FB of 5000 Newton. Determine the deceleration stopping distance. That means he is asking you to find out what is the dx, what is the dc. Stopping distance, time to stop. That means he is also asking us the time to stop. Okay. Time to stop, energy dissipated. So energy dissipated, that is again another aspect. So energy dissipated ED. Then the brake power. So power, you can say power at initial application and averaged over stop, neglect aerodynamic drag and rolling resistance forces. That means drag is to be neglected, and rolling resistance to be neglected. सर कैसे करेंगे सर? अभी पहले तो सर आप डिसलरेशन का फॉर्मूला से इसका स्टॉपिंग डिस्टेंस निकालो सर, सॉरी डिसलरेशन निकालो. Shall I shift to next page? Anybody is having any difficulty on this particular page? I hope किसी को difficulty नहीं है. आगे बढ़े क्या? चल, तो सर अभी नेक्स्ट पेज पे हम लोग अभी सॉल्व करते हैं. तो सर सबसे पहले तो अभी dx is equal to your fx by m. तो सर fx उसने ब्रेकिंग फोर्स ही दिया है, दिस इज इक्वल्स टू fb डिवाइडेड बाय m, that is equals to 1 2 3 5000 divided by 3635. So this comes out to be 1.37 मीटर पर सेकंड स्क्वायर. सर इसको वेरीफाई करो, ये करेक्ट है क्या? 1.37 मीटर पर सेकंड स्क्वायर. सो दिस इज डीसेलरेशन. चलो फिर अभी स्टॉपिंग डिस्टेंस एस डी का फॉर्मूला क्या है विदाउट एरोडायनेमिक ड्रैग वाला? इट इज इनिशियल स्क्वायर ऑफ द इनिशियल वेलोसिटी इनटू 2 टाइम्स डीसेलरेशन, दैट इज dx. सो इट इज, अभी ये 60 किलोमीटर है, 60 किलोमीटर पर आवर. तो अभी इसको मल्टीप्लाई करते हैं ऊपर 10⁻³ ये हो गया मीटर, आवर का 3600 ये हो गया सेकंड. ओके, सो ये इसका स्क्वायर करेंगे डिवाइडेड बाय 2 टाइम्स इंटू 1.37. सो सर इसका कितना वैल्यू आता है बताइए? ये 16.66 का स्क्वायर डिवाइडेड बाय आपका कितना आता है 2 इंटू 1.37. सर इसका वैल्यू बताइए सर कितना आता है तो डिसेलरेशन का? 101.05. चलो ठीक है, मेरा यहाँ आंसर आ रहा है 102.29 मीटर. चलो जस्ट चेक करिएगा, कुछ कम ज्यादा हो सकता है. चलो ठीक है, ठीक है. नाउ स्टॉपिंग टाइम निकाल लीजिए सर. तो ts is equals to v0 by dx. It is easy, 16.66 meter per second divided by dx is 1.37. So stopping time comes out to be 12.16 second. Please verify this. सर सही है क्या? स्टॉपिंग टाइम देखिए, हाँ 12.16 सेकंड. ओके, नाउ एनर्जी डिसिपेटेड. So ED, energy dissipated, is equals to half mv0 square v initial square minus vf square. अभी हमको मालूम है कि vf is 0, तो it is 3635 and divided by 2 in bracket 16.66 का स्क्वायर माइनस 0 का स्क्वायर, ब्रैकेट कंप्लीट. तो सर ये देखिए, ये 504457.3 जूल्स इतनी आती है सर एनर्जी डिसिपेटेड. आप इसको वेरीफाई करिएगा सर. आई 04.46 किलो जूल. हाँ चलो ठीक है, 504.46 kilojoule. Yes, that is correct. Now the power dissipation at the point of brake application. The power dissipation at the point of brake application is simply brake force times the forward velocity, because that much power is going to get dissipated. So power initial is equals to FB into VI, that is V initial velocity, or V0 you can say that is equal to ये आपका 5000 multiplied by 16.66, so that comes out to be 83300 watts. Please verify this. 83300 watt. Now average power over the stop, this is equals to m by 2 half v0 square over the time ts. स्टॉपिंग टाइम उतना लगा, इनिशियल पावर इतना है, तो एवरेज पावर आ गया है आपका 3635 डिवाइडेड बाय 2 इंटू 16.66 होल स्क्वायर. स्टॉपिंग टाइम आपने निकाला है 12.16 सेकंड्स का निकाला है, यहाँ कहीं तो भी स्टॉपिंग टाइम है, सो उसके ऊपर डिवाइड हो गया, डिस्ट्रीब्यूट हो गया, सो इट इज कमिंग आउट टू बी 4148.4.9 watts. तो 41.4849 kilowatts. So this is the power which got the average power over the stop. So this is how we can solve the problem. I hope it is clear to you people that how to do this. सर समझ में आई क्या बात? किसी को कुछ डिफिकल्टी है क्या? चलो नहीं है, बिकॉज ये सिंपल प्रॉब्लम है. अभी सर हम लोग ब्रेकिंग एफिशिएंसी की बात करते हैं. ओके, तो व्हाट इज ब्रेकिंग एफिशिएंसी? सर ब्रेकिंग एफिशिएंसी का कॉन्सेप्ट थोड़ा सा सिमिलर टू फ्रिक्शन है. कोएफिशिएंट ऑफ फ्रिक्शन दैट कम्स आउट टू बी ब्रेकिंग एफिशिएंसी comes out to be equal to the coefficient of friction. So let us see how we do that. Okay, what is braking efficiency? The force or resistance applied to stop a vehicle or reduce its speed is known as braking force. Okay, so ये तो आपका, पहले तो हम लोग ब्रेकिंग फोर्स का बात करते हैं. So braking force is basically the force or the resistance, the force or resistance applied to stop a vehicle or reduce its speed. Okay, then braking efficiency eta is denoted as the braking force divided by weight of vehicle. So into in percentage अगर लेते हैं तो, so braking force is, let us say, FB, weight of the vehicle, N. But so let us say at eta is equals to 100%, you can say that the braking force is equals to weight of vehicle, but eta is usually less than 100% because सबसे पहली कंडीशन, insufficient road adhesion, and vehicle is on down gradient, maybe vehicle is on down gradient, brake system may be ineffective. Brake system may be ineffective because when you apply the braking force, the complete braking force doesn't get transferred to the brake shoes, it gets lost. So eta braking is basically is similar to coefficient of friction, that is mu, because your mu is equals to friction force divided by normal load. So friction force, obviously it is braking force divided by normal force, and so from here you say that this braking efficiency and as normal load is equals to, because normal load is equals to weight of vehicle. So you can say that eta B is equals to 100% if mu is equals to 1. So is it possible that the coefficient of friction is equal to 1? Sir, possible है क्या? Coefficient of friction equals to 1. क्यों सर? क्या होगा? What will happen? Saurabh, what will happen if it is equal to 1? सर बताइएगा. Shall I shift to next page? Sir, please say yes or no. If you have any difficulty, please do ask. Shall we shift to next page? चलो. तो सर कोएफिशिएंट ऑफ फ्रिक्शन 1 से ऊपर रहता है क्या? आप गूगल करके देखिए, आपको कोएफिशिएंट ऑफ फ्रिक्शन का वैल्यू 2 तक के मिलेगा. And there are combinations which are given for which that value is more than 1. Okay, so don't be under impression that the coefficient of friction cannot be equal to 1. Okay, so ये सर थोड़ा गूगल करके देखिए, आपको मिल जाएगा. कंक्रीट के लिए है वैल्यू 1 के ऊपर. नाउ determination of braking efficiency. So we can say that energy of motion and work done, that means the work done to bring the vehicle at rest. So work done to bring the vehicle at rest is equal to average braking force into the stopping distance or distance traveled. This is equals to average braking force into distance traveled after application of the brake. So this we know. Now when braking to vehicle in standstill position, that means the kinetic energy of vehicle is equals to half mv square. So when the vehicle stops due to braking, then due to work energy principle, we can say that FB braking force into distance traveled has to be equal to half mv square. Do you agree with this or not, sir? ओके सो एक काम करते हैं अभी इसको एफ बी इंटू एस इज इक्वल टू हाफ इसको वेट ऑफ द व्हीकल डिवाइडेड बाय जी इंटू वी स्क्वायर लिख देते सर. अभी इसको थोड़ा सा अगर सिंप्लीफाई किए सो कैन वी राइट डाउन दिस FB divided by W, that is equals to half V square divided by G into S. This is okay? Yes or no, sir? Okay, so from here you can say that this is your braking efficiency, because just now we derived this equation. So braking efficiency is equal to V square divided by 2 times GS. This is the expression. Also your FB by W is equals to mu. ठीक है, तो ये सर आपकी ब्रेकिंग एफिशिएंसी हो गई. सो फ्रॉम अबव एक्सप्रेशन it can be said that the braking efficiency is independent of mass of vehicle. Do you agree with this? Okay, now one more thing, eta B is directly proportional to V square and eta B is inversely proportional to stopping distance. So this is the thing which we conclude from this particular expression. तो सर इसमें किसी को कुछ डाउट है क्या? Sir, do you have any doubt? If you do not have any kind of doubt, then we will discuss one small topic, the weight transfer phenomena during braking. सर आगे बढ़े क्या? ओके चलो क्लियर. नाउ विल डिस्कस द phenomena of weight transfer phenomena during braking. So weight transfer phenomenon during braking. So sir, this particular thing will answer your query. Okay, sir, when you apply the brake, the kinetic energy and weight of the vehicle will act through the CG which are above the ground level. So what happens when you apply the brakes? The vehicle will pitch in the forward direction as the brakes are applied. As a result, some weight of the vehicle from the backside is effectively transferred from rear wheels to front wheels. Okay, and weight transfer phenomena cause front brakes to absorb more kinetic energy than rear brakes. Okay, so I will just write down this to make you understand. Let us say that ये सर प्लेन रोड है. अभी वेट ट्रांसफर फेनोमेना सर डिस्कस करते हैं कि मान लो कि ये व्हीकल है. Okay, so this is the front of the vehicle. Now the vehicle is moving in the forward direction. So let us say that this is velocity v. This is CG of the vehicle, which is located at some height h. Okay, now you see that this is the kinetic energy of the vehicle in the forward direction, and the weight is acting on the downward direction. So what is say the first point, vehicle weight, vehicle weight W and kinetic energy of vehicle acts through CG of vehicle. Okay, above ground level, that is height h as shown. ठीक है, जैसे आपको फिगर में बताया है. Okay. This causes vehicle to pitch forward when brakes are applied. It causes the vehicle to pitch forward. This you must have experienced. So what happened? As a result, some weight of vehicle, is effectively transferred from rear wheels to front wheels. ठीक है, वो कितना वेट ट्रांसफर होता है? I will just give you the number. I don't have the derivation. Weight transfer is equals to mu. Mu is coefficient of friction height divided by width, that is the wheelbase. This is basically the distance, you can say, as the wheelbase of the vehicle into weight of the vehicle. If V final is equals to 0 and weight transferred is equals to mu h by B into F by G. F is acceleration or deceleration into weight if V final is not equal to 0. Okay, so this is basically the weight which is getting transferred to the front wheel. So this is the in first case, this is in second case. That means if you say that Vf is not 0 and Vf is 0. Okay, so weight transfer phenomena causes the front brakes to absorb more kinetic energy. So we can write down third point. Weight transfer phenomena demands front brakes to absorb more kinetic energy than rear brakes. Okay, so this weight is added to static weight on the front wheels and subtracted from static weight on the rear wheel. Now this, the fourth point, what it gives is important. This weight is added, this weight is added to static weight of front wheels and subtracted from static weight on rear wheels. Hence, the front wheel brakes are designed to absorb this extra brake. Hence, front wheels brakes are designed to absorb this extra energy due to weight transfer. So that is why you will find that in most of the choice is given that you wanted to where would you like to fit the disc brake. So this is basically the reason why you chose to have the disc brake on the front side compared to rear side. Okay. So this is the discussion regarding the weight transfer. We have seen the determination of braking efficiency. We have solved one numerical as well. So the numerical we have solved and we have derived the expression for deceleration with the wind resistance. So if you have any doubt, please do ask. Otherwise, we'll stop here for today. If you have any questions, sir, please पूछिएगा. Sir, any questions, sir? So if you do not have any question, I'll stop sharing. Okay. So over from my side, you can leave the meeting if you do not have any questions. Thank you.